Hi friends, welcome to part 2 of Cisco Certified Network Associate. My name is Rizwan and my mail ID is mmithru@gmail.com. If you have any doubts, please mail me. Okay, in this video we are going to see the very basics of networking and like what is a network and what are the components that we are using in network and some of the important applications we are using in that network. Okay, let's go. First, what is a network? Network, if you open your dictionary and search for the word network, you can find a lot of definition for that single word. But as a networking student, you want to understand what the network is before reading that definition. Okay. For understanding the networking, I want to tell you a story. Once upon a time, there was a king who ruled a country. He need to share some information to his neighbor king. What he do is he wrote a letter and stamp a seal on that letter and gave it to horseman. Horseman carry that letter and deliver it to his neighbor king. This is the very simple networking we are using nowadays. Okay. Imagine that both the kings are PCs. Okay, PC need to send some information to another PC. So what they will do, they will prepare the information and give it to Horseman. Horseman is nothing but your applications. Applications like your web browsers like Mozilla Firefox and Chrome, or your email client, or your like Outlook Express, like that, and your instant messengers. These are all the applications we are using nowadays. So these application, what is the work of the application is they carry your information across the network. So now what is a network? Network is nothing by which the path by which your application carries your data towards the destination. This is the real definition of network. So we are going to build very strong roads to all the destination. Okay. What is the need of network? Imagine that we are having no network in the world. So what we'll do? What we'll do is if we need to share some information to another person, another person or a PC, we will write it in a floppy disk or CDs, compact disk. We will write it in and give it to that person who needs that information or data. So what if I am having more than 1000 PCs? I need to share my information to 1000 persons. What I will do? What I can do? I can't do anything. So we need to share some information. So we need network. Again, if I am having one PC and one printer, that is enough for me. What if I am having 10 PC and one printer? Can I afford 10 printers for every PC? No, I can't afford. So I will share that device across the network. So anyone can use that device and centralize the administration and so. So, as I told you, the carrying of data in floppy disk is also considered as a network, which was named as sneaker net. Okay. Next, if you are writing if you are writing a letter to your friend, what are the facts you need? First one, what you will do is you will write your from address, from your name and your address, okay, and then to address, friend's name, friend's address, okay, so that you can, without this one you can't send any letters to your friend. You need your address and your name and your friend's name and friend's address. Okay, like that. Computer communication or net is also having two types of address. One is IP address and another one is MAC address. IP address is nothing but a 32-bit number which is assigned to PC, and MAC address is a 48-bit number which is burned in your network interface card, which is unique. MAC address is unique, okay, all over the world. So if you want to see your IP address, go to your command prompt and type ipconfig. You can see here 192.168.0.102. This is my PC's IP address. So if you want to see your MAC address, ipconfig/all. You can see here some numbers like C018. This is your MAC address. This is the address which is unique all over the world. Okay. Let's build a small topology in my packet tracer. Okay, I am taking my two PCs, PC1 and PC2. Is it possible to connect both these PCs without a wire? No, it is not possible. So I am taking cable. Okay, I am going to assign my IP address. 10.0.0.1. Don't care about that subnet mask default gateway. I am just assigning IP address, and here 10.0.0.2. Okay, and then go to your command prompt, and for checking connectivity, command is ping 192.168.10.0.0.1. Yeah, I am getting reply from that PC, so I am able to share the data among these two PCs. Okay, this is a simple network I have built. Okay, we are going to see very detailed about IP address and MAC address in later video. Okay, let's go ahead. There are three types of communication. One is unicast. You can see here this PC is talking to this one, so this is a unicast, 1-to-1. This is a unicast type of communication. Next one is broadcast. Broadcast means one to all. If you want to do your broadcast ping, go to your command prompt and type ping 192.168.0.255. Don't confuse. This is a broadcast ping. Okay, by this ping, everyone will answer my question. Example for simple understanding: if I am taking the class and my batch has 10 students, so 10 will every student will listen to my class. So this is a broadcast. Okay, multicast means if I am having 10 students and 8 students know English very well and 2 of them don't know English, means that is multicast. Okay, so next, very first networking device is network interface card or controller. So very first networking device is NIC, network interface card. If you turn your PC and take a look over there, you can find this in your PC. So nowadays it is onboard. There are a lot of things like onboard Ethernet like that. You can see here. This is a PCI. This is a NIC card which is inserted in PCI slot. Okay. What is the work of this network card? Network interface card. So my computer is ready for sharing my data. What my computer will do is it will send it to this network interface card. Okay, my network interface card will turn it into convert it into bits to pass through the wires. Okay, this is what the work of network card. Without network card, your PC can't communicate with anyone. Okay, we can use that PC for home purpose. We can't make it for communication, or we can't access internet like that. Okay, so very first device is network interface card. Next device is hub. Okay, why we need hub? In this, I am connecting two PC with one wire. You can see there are only 4 PCI slots in my in any computer. So, is any possible to attach this PC in my network, this small network? No, I can't attach. If I try, look at. So I can have only 2 PCs in this type of network. I need to use, but my company is not going to stop with 2 PC. It will use a lot of PCs for communication, networking. So for that, new device is introduced called hub. Okay, this is a hub. So what I will do is, I will make this like this. So I can use many PCs I have got. Okay, hub. Let's talk about hub. Hubs is a broadcast device. Hub is a broadcast device. It won't understand IP address and MAC address. What it will do is, if any frame or data come to that, you can see here, it is connected to this port. If if this computer is sending data to this computer, it will go via this port. So what the hub will do is, it will broadcast to every port. I will show you how it is broadcasting. Okay. 10.0.0.3. Okay. Okay. Just ping 10.0.0.2. Press enter. My ICMP my packet is ready for transmission. So let's add. Okay. My data is sent to hub. You can see hub is broadcasting. This is the PC with 10.0.0.2 IP address. You can see here 10.0.0.2. So again it is broadcast. Okay. Hubs don't understand IP address and MAC address. It will flood data to accept receive. As you can see here, once again I am pinging. You can see here my packet is going. Okay. I am sending the packet. It is receiving in this port, so it is broadcasting in remaining ports. Okay. Okay. Let's go ahead. Hub has one domain and one broadcast domain. Before that, what is a collision domain and what is a broadcast domain? So, collision domain is nothing but where is the chance for happening. Where is the chance for collision? It's called as collision domain. Where there is a chance for collision. If I am sending data to this one, at the same time, this PC is sending data to this PC. What will happen? Collision is happening over here. So it has only one collision domain, central device hub. So it has one collision domain, and the broadcast domain is nothing but where the broadcast can be possible. That is called broadcast domain. If I am broadcasting, so as I told you, hub is broadcasting it to everyone. Broadcast is happening over here, so only one broadcast domain. Okay, one collision domain and one broadcast domain. Okay, let's go ahead. Hub is not an intelligent device. So you can look here. I am adding another hub. Okay, let's make bigger topology. I am adding these two hubs and adding PCs. And connecting this PC. Okay, let's start. Assigning IP address 10.0.0.4, 10.0.0.5, 10.0.0.6, 10.0.0.7, 10.0.0.8. Okay, that's enough. If I am pinging, I will change it to simulation mode. PC10. I am ping 10.0.0.1 from this PC to this PC. Let's check what is happening. Okay, my packet is ready. So let's say auto capture. My data is first. What is happening? Look carefully what is happening. It's again broadcasting, and that will again broadcast. So if I am using 3 hubs, I will have only one broadcast only. So if I am sending a broadcast, it is received by all my network. So this is a wastage of bandwidth. So hub is a failure device. We are not using that device. It is obsolete. We are not using that device nowadays. Okay. Okay. What will happen? I will stop capture. If every PC is pinging, command prompt ping 10.0.0.1, I will give -t, which is for continuous ping. -t over here. It will continuously ping that PC. I will set it to simulation mode. Okay, ping -t, ready, ping -t, ready, ready. Okay, let's check what is happening if everyone talk. You can see here collision is happening. Can you see that? Packet will collide with each other and made to data loss. Okay, so this is one of the biggest failure of a hub, so that we can't use hub. Okay, I need a solution for this one. I need to control my broadcasting so that collision can be controlled. So what I will do is I will use a new device called bridge. What bridges will do is it will break the broadcast domain. Okay, I'm going to show you how broadcast is. Okay, let's start. Let's stop our PC. Here you can see request timed out error, which is caused by the collision of packets. Okay. Okay. What bridges will do? Here is bridge. So I am connecting bridge. So let's check what is happening. Orange light indicate that it is not ready. So let's check. This guy's IP address is 110.0.0.3. Okay. Ping 10.0.0.3. Enter. The packet is ready. Giving auto capture. Okay, packet is ready. It's going towards my hub. Hub is setting to bridge. Packet is dropped by bridge. Because how this is happening is, as I told you, every PC has two type of address. One is IP address and another one is MAC address. Bridges will filter the broadcast. Bridges will control the broadcast by their MAC address. Okay. Every time if two PCs are communicating, bridge will note that MAC address for that. See here, bridge having two ports. Okay. This port is ETH1 and 1 bar 1, 0 bar 1 and 1 bar 1. So it will make a table. MAC address and port. So let's say this one PC1 MAC address is AAA, something like that. It will note it for port number 1. BBB, port number 2. CCC, port number 1, sorry, and here 2. Oh, 1. So it will it will make a table like this. MAC address AAA is connected to first port, BBB is connected to first port, and CCC is connected to first port. Like that, for port 2 is also there. DDD 2, E 2, FFF 2. So it will note like this. So when the packet is sending towards bridge, it will check for its MAC address. If the MAC address matches to EEE, it will forward it to this port. Otherwise, it will drop it over here. Let's check by pinging this one. Okay. Ping 10.0.0.4. Okay. ping 10.0.0.4. My packet is ready. I'm giving auto capture. Packet is going towards bridge. Yeah. Yeah, it will check its MAC table. That means its table. So it is in port number 2. So it will send it to this port. Forward it. Otherwise it will drop it. Bridges are the software based device. So it cannot, if there is a broadcast storm over there, bridges will definitely go down. Okay, understand what is the use of bridge? Okay, let's move ahead. Another important device is switch. Switches. You can see here an image of hub. This is a hub. We are not using nowadays. We are not using this hub. Next one, switch. This is a 24 port switch, Cisco switch. Okay. There are a variety of switches you can see here. These are all switches. Okay, let's start. Switches or intelligent device. It will broadcast for first time, and from that communication will be unicast. Okay, let's check. So as you see here, I am removing all these devices and replacing it with a switch. Switch, switch, switch. Okay. Okay, finished. Let's wait for all these guys become orange. What happened to this one? Oh. Okay, let it will take some time. Okay, these guys are looking good. So let's start ping. Going to simulation. Let's open our PC. Command prompt. Ping 10.0.0.1. Auto capture. Packet is going to switch. You can see here it is unicasting, so it is not forwarding it to any other port. It is unicasting, pure unicasting over here. Okay, switches have one broadcast domain and multiple collision domain. Okay, since it is a unicast communication, collision can happen only here or here. So it has one broadcast domain and multiple collision domain. If I am having 24 port switch, 24 port switch will have one broadcast domain and 24 collision domain. Okay, fine, it's over. Oh, stop. Okay, let's go inside our switch and see what is over there. You can see here okay, if you give command show MAC address table, you can see here it will automatically note its MAC address, PC's MAC address to its port, so that it is unicasting. You can verify here. Look at this. Okay. As I told you, command for seeing your MAC addresses. You can see here 001 0001 639B. Okay, let's take a look at the switch. Here it is 001. It is connected to port F0 bar 1. So it will note like this. Okay, it will maintain a MAC address table. It is a hardware based device. Okay, there are several other functionalities with the switch. Switch and routers are the heroes of ccna. Okay. Very last device we are going to see is our hero router. Routers, what are they? So I am having a switch and 3 computers. Imagine that I have a router and switch. I am connecting this fellow to this. So I am changing his MAC address, sorry, IP address. I am changing his IP address as 11.0.0.2. Is that it? After that I am pinging 10.0.0.1. So we can't ping. You can see here, wait a minute, I will show you. Where the packet is dropping, it is dropping over here. Packet is not sending towards the switch because these two are different network. This guy's IP address is ipconfig 11.0.0.2. I am trying to ping 10.0.0.1. I can't complete. Okay. For integrating two or more network, we need a router. Okay. We will see it very soon. Okay. Router is a very vast device. You can make anything with router. So we will see it afterwards. This is routers. You can see here there are several routers. The main work of router is to integrate different networks together. Consider my office is located in here. Oh, sorry. Okay, consider my office is in Mumbai and my another office is in Kolkata. If I want to make these two communicate with each other, I can't do it without a router. I need a router for that. Okay. So you can see here, this is a symbol of router, and this is a PC symbol. This is a bridge, and this is a switch. This is what we need for the ccna. Okay. This is a hub, and this is laptop. Okay. Very last thing, what is a bandwidth? Okay, before that, routers have a broadcast. They never broadcast unless we configure. Okay. Router hits broadcast and they will never broadcast. Router have multiple broadcast domain. Okay. Okay. This is a device used for integrating different networks. Okay. Okay. We will see bandwidth in next video. So that's all for this video. Hope you enjoyed. Thank you. If you have any doubt, please mail me.